Welcome to another video. Today's topic is LCM. So what is LCM? LCM stands for the lowest common multiple. So the lowest common multiple basically means the smallest number that will divide by all the numbers in the question. Okay? So for example, what is the lowest common multiple for 2 and 5? So what you would do is you would list down all the multiples of 2, which is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, and so on. And you do the same for 5. So 5, 10, 15, 20, 25, 30, 35, 40, 45, and 50. Okay? So all of these are multiples. Okay? Now you would look at the multiples of 2 and the multiples of 5, and you would find which number, and you would find the lowest number that is in both the list of multiples of 2 and the list of multiples of 5. So in this case, 10 is the lowest common multiple because it's the lowest number that is found in both multiples of 2 and 5. 20 is also a common multiple, but it's not the lowest. 10 is the lowest. 20 is the next one. Now another example, 3 and 7. Again, you would write the list of multiples of 3. So that's 3, 6, 9, 12, 15, 18, 21, 24, 27, and 30. You do the same for 7. So 7, 14, 21, 28, 35, 42, 49, 56, 63, and 70. Again, you would look for the lowest common multiple. So the lowest multiple that's found in both 3 and 7. So if you just quickly look, 21 is the lowest. Because 21 is the common multiple found in both 3 and 7. That is the lowest. Okay, it's very straightforward. Lowest common multiple. The word explains itself basically. Another example, 9 and 12. Simply just write the multiples of 9. So 9, 18, 27, 36, 45, 54, 63, 72, and 81, and 90. Do the same for 12. So 12, 24, 36, 48, 60, 72, 84, 92, 96, and 108. So you would find the matching number. In this case, it is 36, which is the lowest common multiple. Now, finding low common multiple using prime factorization methods. So when you have larger numbers, okay, it's easier to find the prime numbers and using those prime numbers to find the lowest common multiple. This method is basically faster than writing out all the multiples of the two numbers. So for example, if you're trying to find the lowest common multiple of 12 and 36, it will take a long time to it will take long to list out all the multiples of 12 and 36. So instead, this is what you do. Sorry, not 36, 18. So instead, this is what you do. First of all, you decompose 12 and then you decompose 18 by prime factorization. In order to do that, you divide by factors and then you break it down into prime numbers. So 2 and 6 equals 12. 2 times 6 equals 12. And then 2 and 3, which equals 6. Do the same for 19. So 2 times 9 is 18. And then 3 times 3. So for 12 equals 2 times 2 times 3. And 18 equals 2 times 3 times 3. Now this part is a tricky part. Okay, so make sure you listen. So to find the lowest common multiple, what you do is you circle common prime number in both 12 and 18. So in this case, there is a 2, there is a set of 2 and a set of 3. Okay, now there isn't a second set of 2 or 3 because another 2 is not found in 12 or 18, and another 3 is not found in both 18 and 12. So in this case, you only have these two sets, 2 and 3. So you would put that down there, you would multiply them together. So 2 times 3. And then you would fill in the rest with the numbers that are not part of sets, are not found in both 12 and 13. So you'd fill the rest in, 2 times 3, and then 2 and 3. Okay, and then that would give you 36. So 24 and 36. Find the lowest common multiple by prime factorization. So first of all, break it down, 2 and 12, and then 2 and 6, and then 2 and 3. And then for 36, 2 and 18, 2 and 9, and 3 and 3. So 24 would equal to 2 times 2 times 2 times 3. Let me just write that down correctly. Okay, there we go. And then 36 would equal to 2 times 2 times 3 times 3. To find the lowest common multiple, select sets of prime numbers that match, like this. So there is a set of 2. So 2 is basically found in 24 and 36, and then another set of 2. You would circle that out as well. There isn't a third set of 2 because there are only two 2's in both 24 and 36. So you don't write another set, and you have a set of 3. Okay, this can be a bit tricky, but if you practice it, then it should be easy. So 2 times 2 times 3. Actually, let me write that down clearly. 2 times 2 times 3, and then you fill in the rest. So you have two numbers left, 2 and 3. So you do times 2 and then times 3. Then you would get 4 times 3 times 6, which is 12 times 6, which is 72. So your answer is 72. Here's another example. So find the LCM of 42 and 80. Now pause this video and try do it yourself. See if you get it right. Okay, so 42, you'd break that down into 2 and 21, and then 3 and 7. For 80, you would break that down into 2 and 40, and then 2 and 20, and then 2 and 10, and then 2 and 5. So 42 would equal to 2 times 3 times 7. And 80 would equal to 2 times 2 times 2 times 2 times 5. Find the sets of prime numbers. So that's one set, and that's it. There is only one set. So low common multiple would be 2 times the rest. So all these numbers, you would add them at the end. So 2 times 3 times 7 times 2 times 2 times 2 again times 5. So that would give you 2 to the power of 4 times 3 times 5 times 7, and the answer would be, just use your calculator to find this, 1680. Another example. Find the low common multiple of 56 and 120. Pause this video again and try work this out yourself. Okay, so 56, decompose that, 2 and 28, and then 2 and 14, and then 2 and 7. Next, you do the same for 120. So 2 and 60, 2 and 30, 2 and 15, and then 3 and 5. So 56 equals to 2 times 2 times 2 times 7. And 120 equals to 2 times 2 times 2 times 3 times 5. Find the sets of numbers, of prime numbers. So you have one here, another one here, another one here, and that's it. So 2 times 2 times 2. 1, 2, and 3. And then fill in the rest. So times 3, let's just do 56 first. So times 7, and then times 3, and then times 5. Which equals to 2 to the power of 3 times 3 times 5 times 7, which equates to 840. Anyways, thank you guys for watching. I hope this was helpful to you, and yeah, see you in the next video.